Hello, Sloohers, and welcome to Slooh's Practical Astronomy series with me, Paul Cox, where we can learn to explore space together and get the most out of our Slooh memberships. Now, if you're somewhere on the Slooh website and you're suddenly hearing my voice, hop over to the Situation Room. And you get to that by the left-hand navigation, live cast, and then up to Space Situation Room. And you can join us for this live cast. Or if you are feeling antisocial, you can turn my audio off by clicking the little audio bug at the top of the page. Now, before we get into our topics today, I nearly say tonight, but what are we in? I'm on the east coast of the USA at the moment, so it's evening here. It's evening in South America, but I know there'll be a few folks listening in Australia and New Zealand, so early afternoon there, maybe having Monday lunch even. And well, if you're in Asia, I guess, East Asia, you may be just getting up on a Monday morning. Oh, that horrible feeling. And then, of course, if you are in Europe or maybe the Middle East or South Africa, and we've got some members down there, hi Carol, then yes, how on earth are you managing to stay up this late? And then, of course, people on the west coast of the USA. Where are you at the moment? Oh, I guess you're afternoon, aren't you? So anyway, good morning, good afternoon, good evening, and good night. What was that one? Wasn't that the that show with yeah, you know the one I mean. Anyway, listen. Before we get into our topics today, don't forget that Helen Avery is away this weekend, so there'll be no constellation stories with her at 9 p.m. Eastern. What are we going to do without our Sunday night fix of mythological stories? Well, a poor substitute, for this week at least. I'm going to return at 9 p.m. Eastern, that's in an hour and a half's time, to give you an intro to Slooh's 2018 Members Messier Marathon. Now, if you can't watch that live later on, make sure you watch the recorded live cast, as this really is a great event to participate in. Even if you've done one before, they're always great fun and definitely not an event to miss in the Slooh community. And tonight's Messier Marathon live cast will be the first of 3 that I'm going to be doing over the coming weeks. We've separated them out from this Practical Astronomy series because there was just too much going on in a single hour. But anyway, week 4 is going to be the Messier Marathon itself. That's Saturday, March 17th. Now, if we're unlucky with weather on the Saturday night, we're going to shift the event to Sunday, March the 18th. So make sure you block out your diaries for both of those dates. So anyway, join me later to hear more about that. Now, also, before we move on, actually, I always have to do my thing of I need to check to make sure they're actually seeing and hearing me. Yes, I think you are. I'm sorry. Fancy doing that to you. Anyway, listen, before we move on even more, I spotted some interesting images in the observation log timeline before we went on air. And the observation log timeline is this thing on the home pages where you can share your best images and write something fascinating about it in the right hand side. You do that, by the way, in my picks. If you can skip back over one of the previous Practical Astronomy series and you can see exactly how you can share your image to the observation log. Anyway, I was looking back through these. Nice one there, Messier 10 from J, globular cluster, tightly packed cluster of ancient stars. Another one there from Chile, so I think J's got that one twice. Another globular cluster. Now, this is one of the ones that I thought was really interesting because at first look, it makes this image, and this is grayscale image, so Jay has snapped this at grayscale, and I think it really accentuates what I'm going to talk about. At first sight, this image looks really noisy, but it's not. that's a whole bunch of stars and nebulosity. The actual object that Jay's captured there, NGC 6401, is the tiny globular clusters, this little thing I'm just pointing to in the middle of the screen. But what I found most interesting about this image, because I don't think I've seen this object before, is all of these dark patches around it, and you can see these. Now, is that an area, you might be asking yourself, where there are no stars? Actually, there are plenty of stars there, but they're obscured. These are actually dark, dark clouds of dense dust and interstellar matter. They're dark nebulae. And these are very dark nebulae. They are so dense. And what we've got happening inside those are new stars forming, that even their bright new light, as soon as they burst into life, can't actually make it out of those dense clouds. The Eagle Nebula, the Pillars of Creation, if you remember that image from the Hubble Space Telescope, that's a very similar kind of very dense knot of dust and gas which is forming stars inside it. But let's take a quick skip back through another globular cluster. Hey Jay, you're building up quite a good collection of globular clusters there. And of course, this week is a great week to image bright objects like globular clusters, because we've got moonlight spoiling the view. And in fact, we'll maybe take a look at the Chile telescope in a minute, and I'll explain why. So what do we got there? A little blue planetary nebula there. Pretty small. I think you need to click that one to go up. Oh, now that's looking nice. That's another little bug-type planetary nebulae, but there was an even better one here in somewhere. That's the same one. Now, that I thought was quite interesting. This is a galaxy side on, which, by the way, if you haven't had a look at the we'll take a look a bit later, actually, in the discussion boards of Carol from South Africa, her Hubble tuning fork diagram. Wow! If you want to learn about different types of galaxy, it's called galaxy morphology. And Dr. Paige Godfrey did a show about it. I think it was 2 weeks ago, or 3 weeks ago actually, and she asked people to create what's called a Hubble tuning fork diagram, something I've been meaning to do for ages, but actually Carol's efforts, superb efforts, have spurred me into doing my own version. But what I thought was interesting here is there's obviously a very bright object down here at the bottom, which is kind of shining into the image. It's kind of making some reflections in the telescope, and this is why I just thought we'd go through some of these, because I wanted to explain to you a couple of the problems that we get. And this is the image I wanted to show you. This is from Daryl S. I know Daryl's watching tonight, so we've got a question from him a little bit later on, actually, about the Messier Marathon. But this is Canary One. Now, if you missed it, Canary Islands Observatory was open last night. We had a break in between winter storms, in between one winter storm and another winter storm. And he grabbed this image, and I watched this mission live, and it was really disappointing. You can see here that it's all a bit blobby and horrible, and there are kind of these teardrop shapes coming down from the stars. This is an absolute classic example of when the winds are too high for the Canary One Telescope. And shortly after this, actually, it closed because the winds got above its high wind limit. But it hasn't stopped 5 people liking it. But I know a lot of members out there have not yet seen the Canary One Telescope when it is singing along. But look at this one, Chile 1. Wow, Chile last night, and actually over the last couple of nights. Absolutely brilliant. Even despite the moon, we've had some really, really good seeing conditions. That's how stable the image is. And this is the last image that I wanted to show you. The 8 burst nebulae, a bit like the Ring Nebula. And in fact, that's exactly what Jay's called it, the Southern Ring Nebula. But look at this. So that's a star like our sun, actually, yellow dwarf star, which is shedding off its outer layers at the end of its life. Pretty sad story, really. But anyway, listen, let's get back to tonight's livecast. What are we going to cover? Well, to ensure we get to your questions tonight, because I've failed miserably with my timekeeping over the last few weeks, we're actually going to do your questions first. Now, don't forget, if you have any questions about Slooh's observatories, telescopes, or using Slooh, then post them to the livecast topic in discussions, and I'll do my best to answer them during the broadcast. And if you have any suggestions for topics you'd like me to cover during these, then do post them there too. So we'll be hopping over there in a bit because we'll be taking a look in here. And what else are we doing tonight? Well, Pluto. We are going to be finishing off the exercise we started last week, celebrating the 88th anniversary of Clyde Tombaugh's discovery of Pluto. And we're celebrating it by replicating it with Slooh's telescopes. I'm going to show you exactly how to do that later. Even create your own time-lapse animation. It's easier than you might think, so make sure you stick around for that. We are going to be looking at, during that, the images we gathered using the Canary One telescopes this week, before stepping through all that process of identifying Pluto in those images, and even a little image processing to align those images before we then create a time lapse of the images. And I know there's a recent post, somebody's done one tonight. Muraz has done a Pluto animation, so we'll take a look at that maybe later while we talk about that. But then, of course, we are going to be delving a little bit deeper into Slooh's observatories and telescopes. We'll be covering the telescopes in more detail when we can actually watch them all live during the live cast, and we're certainly going to need better weather than we've got for that in the Canary Islands tonight, although Chile is online. But anyway, tonight we'll look at the observatories in more detail, and also the common features across each telescope system. And that's what's called primarily the image train, the equipment that's attached to the telescopes to capture our data. That's basically focusers, filter wheels, and of course the expensive, highly expensive, ultra-cooled CCD cameras. Now, we've got plenty to get through, but let's kick off with a look at the conditions at the observatories. So I added a cool little panorama image. If you're in the sit room, go to what's called graphics one, that little tab underneath, and this is actually a panoramic image of the Canary Islands Observatory. Now, it's not daytime there. That very bright thing in the second image along is actually the moon. But you can see we are well and truly in the depths of yet another winter storm. And in fact, this one's even so bad that I received a warning email from the IAC, the Institute of Astrophysics of the Canary Islands, about the government there warning of incredibly high winds. But let's take a look down. I just wanted to remind you of how to find out really the observatory's conditions. So here we are. I'm going to telescopes. It's green because it means one of the telescopes online. Canary One is green, so we can hop off to that. And there's a classic example of what I was going to talk to you about. Another thing I was going to talk to you about tonight. Why on earth is that image green? I mean, it's beautifully matched, isn't it, with our mask, with our framing of this live image stream. But astro images aren't meant to be that color. But the problem is we've got moonlight tonight. The ultra wide field there, look at that, that's got a cast on it. So in fact that cast is two colored, which means we may have some light cloud. But anyway, I wanted to show you how do we find out the conditions tonight. Well, we can hop over to the weather and we can see that tonight we got a chance of high humidity. Actually, look, we got a couple of days chance of high humidity. Need to keep an eye on that tonight. Let's have a look at the current conditions. Humidity 66%. That's not unusual. For the Chile Observatory, we have to run what's called dew heaters that keep the optics just marginally above this temperature, the temperature that says dew point. So our dew heater at the moment will be heating the glass on the telescopes to about 51, 52 degrees Fahrenheit, something like that. Because as long as the optic stays just 1 degree above the current dew point, dew won't form on it. And you don't want to heat it too much, because if you heated it more than necessary, then actually you're going to get quite a lot of convection coming off that. And that basically is, well, you look along the road, you look along a tarmac road, and you can see what it would do to our views of the stars. Let's have a look at the satellite image. Can't really tell too much from that. Mission status, yeah, so that was last night. Let's take a look at the all sky. So I've got to get the technicians down there to clean this, haven't I? There is the moon. Can't see any haze, but in fact, that's where our nice time lapses come in. And if you haven't had a look at the time lapses yet, you should do so, because you can actually see. That's still during daylight. So here we go. Sunset. It's a lot easier to see. We're not quite far enough into the night to see all of that. It's a lot easier to see light cloud and haze in those time lapses. That's especially true of the all sky camera in the Canary Islands. So when that comes back online, oh, that's pretty cool, isn't it? Another globular cluster. That's another new one on me. NGC 104. No, I know that one. So okay. Oh well, thanks, Peter S. I'm going to take a snap of that. Thank you very much. And like in the wide field. That's nice. Take a snap of that. Thank you very much. Right, anyway, so those are conditions at the observatories. Now, let's get on with your questions that you've posted to the discussion boards. If you haven't been to the discussion boards yet, why not? Hop over to community in the left-hand bar. You can go to most recent, or you can go to featured threads. We'll go to featured threads, and you'll always find, for all of our shows, for pages, intro to astronomy shows, Helen's constellation stories, my practical astronomy, or the Messier thing, you'll always find a pinned post to featured threads, so they're nice and easy to find. So anyway, let's take a look down. In fact, let's just take a look while we are here, because we've got plenty of time tonight. Let's take a look, see what's been happening this week. So we've got Pluto animation that we'll take a look at later. Dave was pointing out a problem with the Canary 2 telescope last night, so if you're interested in that. Oh, one pab and yet another glorious image, and he's been using some of the Canary 2 data that he's been collecting, and this one is absolutely stunning. The fireworks galaxy. Look at that, and look at the star colors that Juan Pablo has managed to capture here. And this is with the Canary 2 telescope. Wow, I love that. Now, this actually, although it looks like quite a bright galaxy, is an incredibly difficult object to capture, because it's actually quite faint, and it appears quite faint because it's quite diffuse. You know, maybe I don't know what people did in their Hubble tuning fork galaxy morphology things, but you know, this is really quite an even, quite a perfect spiral galaxy, isn't it? So it's a bit like a pinwheel, or what we call in the UK a Catherine wheel, which is a certain type of firework. But there it is, absolutely glorious, and that really is a difficult object to capture. So nice work, Juan Pablo. Oh, now we've got to have a look. We've got to have a look, because if you haven't seen this week, it really is cool. So a few weeks ago, Dr. Paige Godfrey did a show about intro to astronomy show about galaxy morphology, and she challenged all of us to create what's called a Hubble tuning fork diagram. And this is something that Edwin Hubble created in the 1920s, I think it was, to classify, to categorize different types of galaxies. And I'm not going to go on anymore, because picture paints 1,000 words. Take a look at Carol's example here. So this is a Hubble tuning fork. So you know a tuning fork that a piano tuner uses? The top of it, the 3 or 4 spots at the top, would be the handle, and then you have the 2 forks. Ignore the ones in the middle, the intermediate ones. So the two, the kind of the bit that looks a bit like a scorpion, I guess. So this is how Hubble classified galaxies. And you can see they run all the way from these elliptical, fairly kind of amorphous galaxies without very much definition in them, down, into being lenticular, which are quite spread out. And then you've got the barred spirals on the left, which I think, the barred spirals are my favorite types of galaxy. And actually, the middle one here that Carol's used, NGC 1365, is one of my favorite objects to view through the Slooh telescopes. It looks to me like it should be, Star Trek's, their badges that they used to tap. It looks like it should be something like that, a lapel pin of some kind. But there it is, this barred spiral galaxy. And then on the other side, you've got the spirals. Now, the fireworks galaxy that we just had a look at, that's going to be right down at the bottom right-hand side because it's incredibly even. So anyway, take a look at that. And if you missed Dr. Paige Godfrey's show about that, then do that. And keep following this thread because I know a few other people here have said they are inspired to do one of these as well, including myself. I'm going to do a slightly modern riff on mine, I think, using actually some of the image processing techniques that we're going to be looking at a little bit later. Keith's been looking at... Keith Smith from Down Under is another Jupiter fan, just like me. And take a look at this. And Keith caught the end of what's called a shadow transit the other night. So here we are, image of Jupiter. We can see here Keith very kindly has marked up the moon, Galilean moon Io, Ganymede and Europa. You might say, well, where's the other one? Where is Callisto? Well, Callisto is probably outside of the field because it's got a very wide orbit. It's possible it could be occulted by the planet at the moment, behind the planet, in other words. But what Keith has managed to capture here is Ganymede's shadow. Now, there are two spots on the top of Jupiter here, one of which, unfortunately, is a hot pixel. Pixel on the camera that is incredibly annoying when it comes to Jupiter missions. But the other one is Ganymede's shadow being cast right on the northern pole of Jupiter. And we're going to start seeing more and more of these Jovian phenomena. Shadow transits, moon transits, occultations, eclipses. Jupiter has it all. And I'm actually going to show you a little trick later on how you can improve really simply. Don't need any image processing skills to improve your Jupiter images. Anyway, I thought that would be quite nice just to skip through that little lot. But let's take a look at your questions, the first thing that we're coming to tonight. So actually, that's why we went over there to begin with. God, attention deficit disorder or what, Cox? So this is where people have been posting their images. And we've got one here. Margaret F. Very patient, thank you, because you asked this last week. Does increasing magnification decrease an object's brightness? And how does it relate to choosing a telescope to use to view an object, especially a comet? Right, okay, so we don't really use the term, and we'll go into this in more detail when we go into detail on the telescopes. So we don't really use the term magnification when it comes to telescopes with CCD cameras on. What we talk about instead there is the image scale. So if you do the equivalent of increasing the magnification, then yes, it does. It doesn't decrease the object's brightness, but it certainly decreases the object's, the number of photons that you can gather up for that object. So we will go into quite a lot of detail in that, because these are really important kind of fundamentals about the way telescopes work with CCD cameras on the back instead of eyepieces on the back. And if you do have a telescope yourself, so many people are always tempted to put their highest power eyepiece in the back of it to give it the highest magnification. But 9 times out of 10, the conditions aren't good enough. So in fact, all you do is you see something more blurred than you would do if you'd used a lower eyepiece, a lower power eyepiece, and which gives actually a wider field of view. And that's also what we're going to go through there, Margaret. But you've also asked about binning there. Could you explain binning? Well, actually, I'll take you somewhere where there's more information on this. Now, under featured threads, you'll remember that we've got this topic that we're keeping here at the moment, which is the observatory information and telescope specifications. And what you'll see in here, the very last item, Canary Eyes Processing Options Exposure Guide, if you take a look at this, you will start seeing this term that Margaret's asking about. Binning, it says generic processing option is taking 3 60-second exposures, binning 3 by 3. But here we've got bright star recipe taking it, binning 1 by 1. Imagine on the CCD chip, there are a lot of people call them pixels, but they're not really pixels. They're actually called photosites, but they're the kind of equivalent of pixels on a CCD chip. And those CCD chips are made up of thousands of them, just like your own digital camera. You know, they're megapixel cameras. So what happens though in astronomical CCD cameras is most of them are grayscale, and that's why we take images, Margaret, through different filters. Now, binning. If we're binning 1 by 1, it means that every single photosite, every pixel on the CCD translates in your finished image to 1 pixel. Now, a lot of the time, we're interested in making a telescope system and a camera as sensitive as we can. And to do that, we can do this really clever thing with astronomical CCD cameras, which is called binning. Now, if you bin, by the way, think about this binning 1 by 1 and that photosite as being your little fingernail. All right. And imagine the amount of light, the number of photons that hit that area of your little fingernail. Well, the clever thing that we can do with CCD cameras is we can say, actually pick the pixel next to it and the 2 pixels next to that to make up a square of 4, which would be binning 2 by 2. Treat those 4 photosites as 1 single photosite. So instead of having a single pixel the size of your fingernail, your little fingernail, you're suddenly collecting photons on a space, on an area the size of your thumbnail, 4 times larger, which means that you're increasing the sensitivity of the camera. And then if you go 3 by 3, you're joining together 9 pixels, 9 photosites to act as 1 photosite to collect as many photons as possible because you've increased its area. So you might say, well, why don't we do that all the time if it's such a good thing? Well, there's always a payoff. Now, a lot of people think that binning reduces the field of view, but it doesn't actually have any impact on the field of view at all. But the downside is it reduces resolution. All right, so you can actually see here, there's a note for the bright star recipe on Canary One, and we use binning 1 by 1 because we don't want sensitivity. We don't need sensitivity when we're imaging a really bright star. So we image at its maximum resolution, binning 1 by 1, where each photosite equals 1 pixel in the finished image. But you can see here that we've got a little note here that we actually resize those images to 3 by 3 binning. In other words, we just reduce their resolution. Otherwise, the file sizes are so large, 18 megabytes each, and on Canary 2 it's even larger than that, which would not be that useful to too many people. So that's binning. It's a way of increasing the sensitivity of a CCD camera. So now, if you've got any questions like that, or you want me to follow up on anything that I tell you like this, then let me know. Just post to, the live cast each week, and and I'll expand on it. So what do we got? Jay's here. Jay's saying, have we got any more images of the Chile setup? I will certainly try and share some a little bit later, but I might have to dig some of those out actually, Jay, because you might be interested in seeing some of the construction photos for the Chile Observatory with its 3 piers. It's got 3 piers in there, ready and waiting for more, please, more members, which means we can afford more telescopes. Now, interesting post here from Tony E, which is related to the subject we're doing a little bit later. And he was saying he's done some great detective work, actually. He was saying that a post a while ago was talking about another moving object in Clyde Tombaugh's Pluto discovery images. Now, he did this detective work, and using the skills he's honed as the leader of our near-Earth asteroid group, he's identified another moving object in there, which is 2597 Arthur. That is the main belt asteroid, and it was the 2597th main belt asteroid to be discovered. And Tony was asking in here whether or not I had any the individual images I took, so I sent him that, and he came back and he did this great little image. And is that the one that's showing? No, that's showing Pluto. I think he's got another one in here somewhere, which is showing Arthur. Yeah, there's Arthur. So the top little blue arrow is showing main belt asteroid Arthur. And one of the interesting things actually that came out of this little discussion with Tony here is, I was saying last week when I was describing the discovery of Pluto that Clyde Tombaugh has these 20-inch glass plates. They were his film, if you like, that he was using in this enormous camera strapped to the back of his telescope. And I was talking last week about how long an exposure time he had to take to get his images. And don't forget, this little blink comparator here, these are his images. His images to capture Pluto were an hour long. That's how long it took. And the reason why we were able to establish that was Tony saw the line. He saw the movement that asteroid Arthur had taken during the exposure of that frame from Clyde Tombaugh. And he could then work backwards and work out that Arthur, over to cause a little streak like that in the image, the exposure would have been about an hour long. There you can see it. So thanks for that. That was really interesting, Tony. Thank you. Yeah, kind of added to our conversation here. David H asked a question about the IC catalogue. So you'll know that for astronomer members, let's take a look. So we'll go over to telescopes. We'll go up to scheduled telescopes, and you can see here, an astronomer member can schedule by catalogue. So here we are, and you can see the IC catalogue here, first and second index catalogue of nebulae and star clusters. Let's try 101. No idea about these. Check visibility. Working. Cannot be imaged at this time. I just picked one from anywhere. But anyway, Tony gave a great answer to this with a chronology of the development of Herschel's original general catalogue, evolving into the new general catalogue, which we talked about last week and the week before, and the 2 index catalogues, that's these IC catalogues that David was asking about, created by John Dreyer, that supplemented the new general catalogue, the NGC. So, yeah, the first major update to the NGC was the index catalogue of nebulae and clusters of stars. And it was, as Tony says here, it was published by Dreyer in 1895, which had, I think, 1,500 objects in it. I don't know if Tony's got that on here, can't see. But there was the second index catalogue was in 1908, and that contained 3,866 objects. So both of those kind of supplement the new general catalogue. David was also asking about the difference between a parsec. Where was that? I think further down here. Yeah, Tony hasn't quite got this, has he? Tony needs to come on air if he needs to answer these. Thank you, Tony. Very helpful. Tony is a long-time Slooh member, and he runs the Near-Earth Asteroid Monitoring Group and has mentored many members through that process. But anyway, David was asking about the difference between a parsec and an arcsecond, and they are two quite distinct units. A parsec is a unit of astronomical distance, and it equates to 3.26 light years. A light year being a measure of distance as well. It's the distance light travels in an Earth year. A parsec kind of is related to 1 second of arc, but only in its definition. Its definition is the distance at which the mean radius of Earth's orbit subtends an angle of 1 second of arc. Now, I should have had a diagram ready for you for this, but Tony's got a nice link actually there to the Wikipedia article. But anyway, so what is an arcsecond, or 1 second of arc? Well, that's a unit, it's an angular unit of measurement. And in astronomy's case, it's a measurement of an angle in the sky. And the 4 units we tend to use to measure angles are degrees, minutes, and seconds. There are 60 arc seconds in a single arc minute, and 60 arc minutes in a single arc degree. And we can see how it relates to angles in the sky by looking at our planetarium software. So let's hop over to a slightly different screen here. Hopefully you'll be able to see this. Come along. Why aren't you showing up? Oh, there you are. Oh, there you go. Right, so there is the Sky Planetarium software. So let's take a look at our fields of view. Let's hone in on the moon, shall we? Because the moon's always a good thing to look at when you're looking at fields of view, because it's, you know, it's an object that we're familiar with. We kind of know how big it is in the sky. Just rotating it round so it's north and nice pretty. Let's zoom out a bit. So you can see there that inside blue rectangle is the field of view of the Canary One Wide Field Telescope. The outer blue is the Canary One Ultra Wide Field. I haven't got the other telescopes loaded in here, but if we hop up to the specifications for this, I'm not sure if you can see this. No, you can't. So you can't unfortunately see my overlay. But these fields of view are measured in arc minutes. So for example, the Canary One Wide Field Telescope is 31 arc minutes by 21 arc minutes. So we know 31 arc minutes is about half a degree. Going over to the Canary One Telescope, that's 37 by 37 arc minutes. The largest field of view that we've got currently is let's have a look, the Canary Two Ultra Wide Field, which is 107. So well over a degree and a half wide, and 72 arc minutes high. So that's over a degree high. And then we've got the Canary 3. Yeah, the Canary 3 deep sky is 99 by 95. So, but it's not just a way of measuring that. If we actually have a look in the left-hand side, we've got the moon selected at the moment. So all this information in the left-hand panel is actually telling us loads of information about the moon. And here we can see moon angular diameter, 32 minutes, 42 seconds. That's how big it is in the sky. The moon, we know, is about half a degree in the sky. But if we would look for another object, let's take a look for Jupiter. We can center in on that. We know that Jupiter looks smaller in the sky, but if we scroll down here we've got apparent angular diameter 39 arc minutes. Sorry, arc seconds. So there it is. It's a great measure. Now, Jupiter, as we'll see a little bit later, when I'm going to show you how to tweak your Jupiter images really easily, is pretty big in the telescope views at the moment. But Mars is still looking pretty lousy. And look, there's the reason. So Mars is currently only 7 arc seconds across. It is so small that it's really not looking very good in the telescopes at all. So anyway, that is arc seconds and parsecs. Now, let's have a scoot back to our questions over here. I know we got one from Daryl here. Daryl, he's got some questions about apprentice members participating in the Messier Marathon. I'll cover those in this separate live cast in an hour and a bit. No, it's in an hour actually. In an hour's time. Tony Evans also shared this great little thing that we're going to move on to next. Actually, he's taken a couple of the images that we did this week and he's animated them. I'm going to show you how to do that in a few short seconds. Now, Tony, by the way, says he used the Fitz data for his exercise. Now, for those of you who don't know, Fitz format files are generated by astronomical and some other imaging CCD cameras, usually some of those used in specialist medical facilities for medical imaging. They use CCD cameras very similar to ours. In fact, some of the manufacturers make cameras for both purposes. But Fitz file formats, they contain information that's lost when it's converted to many other forms of images. So astronomers use Fitz data for astrometrical and photometric measurement. So astrometrical is positional data. That's what Tony and the near-Earth asteroid gang normally do when they're measuring the precise location of near-Earth asteroids and comets. Photometric measurements are about an object's apparent brightness, and that's what you're measuring there. But Fitz files are also used by people who want to do their own image processing, although I'm going to be showing you in future weeks that you don't need to get into the complexities of Fitz files to be able to do some pretty cool image processing. Anyway, Tony's post is probably an opportune moment, isn't it, to jump off into our first topic tonight, our first main topic tonight. Anyway, I'm glad I managed to cover all those questions. Now, don't forget, if you've got any more, then throw them underneath here and we'll deal with that. But we are going to finish off our exercise in replicating Clyde Tombaugh's discovery of Pluto that he made 88 years ago. So you can see Tony's example there. But let's hop over and do one ourselves. Now, I am going to go through this quite quickly. So don't worry too much about how quickly I go through. And I need to set up the right screen. We'll take that off. We'll put this on. Transition. There you go. Right. Now, if you didn't manage to piggyback, I just need to make sure you are seeing this. Yes, you are. If you didn't manage to piggyback those missions that we had during the week to Pluto at the end of the night at Chile, listen, I'll tell you what we're going to do. I am going to overrun tonight. So I'm going to change the end time of this show. But what will happen at 35 minutes past the hour, that's in 20 minutes time, you will get cut off. All right, so I'm just going to add on minutes. The show will end. Just refresh the page and you'll catch up with it. So I've just added on a few minutes to the end of the show because I would like to get through a couple of these things. So I don't know. Do you prefer the leisurely pace I'm trying to do with these things, or do you prefer the fast pace and we get through everything? I prefer these lower pace. But anyway, look, if you didn't manage to capture these images yourself in the live missions, then you can download them because I put them all in the post. Right, so you can download all of them. But this is our first image, and this is from the 21st, so the morning of the 21st. And what we're going to do is, somewhere in this image, we know roughly in the center of the image is the dwarf planet Pluto. I'm going to flick on to the next image, and what you have got to do is try and spot the object that moves. I'm going to flick back and forward between them. Now, if you keep your eye roughly here when I flick to the next image, you're going to see something appear. Bing! There it is. Can we see where it disappears from? Yes. So in our first image, there's a little speck here, just where I'm pointing with my cursor. And we flop over to the next image, and it flips over to here. So immediately we know the kind of direction this is heading in. Let's hop over to our third image. Now that's more difficult to see because there may be more of a time lag in there. So I can't see that. Can you see it, folks? And then the final one. So look, just by flicking between those first two images, you're really doing what Clyde Tombaugh did way back then, albeit on your computer. But there are far, far easier ways of doing this. What's making this really difficult for us when we flick through every single one of these? I just caught it again there. So it's up here very close to this star. So is the pointing of the telescope, the accuracy of that changes night on night. So although I use the same coordinates to set up these missions, you can see the star field is kind of moving around a little bit. All of that movement is very, very distracting to our eyes. So what I would like to do is show you how to align images. Now, there's a couple of programs that can be used for this purpose. You'll be sad to hear that actually I'm using the most expensive one for us tonight. But let me just get rid of something on my screen. We're working my machine hard tonight. There we go. Right, so hopefully now you can see Maxim. Now this program will cost you the same as a year's Slooh membership. In fact, it will cost you, at least a year's Slooh astronomer membership. But if you have a look in the discussion boards, you will see Dave Larkin has been scouring the internet for donkey's years trying to find free astro image processing. Excuse me while I have a drink. It's not like a radio show. Unfortunately, we don't have commercial breaks and stuff. And there's one called AstroFX, which is free. Dave tells you where to download it. And you can go through this same exercise. And in fact, on the image processing courses that we are going to be doing later on this year, that's actually what I'm doing at the moment. It's why we've delayed doing those. I could give you an astro image processing course using Maxim tomorrow, because this is the software that I know, I love, I use. But we don't want to force you into having to buy a $300-400 bit of software just to do some astro image processing. So what I'm doing is I'm developing some of that and some of Dave's work actually that he's been doing to show you how to use the freebies. But look, for this exercise, I just want to show you the process that we go through, and it really doesn't matter what processing software you go through to do this. But here are my 4 images loaded up. Now we could go to View, Animate, Add All. Okay, I'm skipping through this quickly, I know, but don't worry. So there it all is, and then we can say animate that. But you can see here, look, we've got this same problem. The images are jumping around all over the place, so it's actually quite difficult. I can see Pluto just appearing, blinking on and off, every now and then. There it is. But it's like chasing, I don't know, a greased pig. So what we want to do is we want to align the images, and in Maxim you go Process, Align. We want to align all of these images. The first one is the one that we're going to use as our reference image. We're going to use the star matching alignment routine. I usually do an overlay all images so I can see if it's worked well. It has. I can say OK to that. Now, what we've done is all of these images now are perfectly aligned to each other. So if we go back to that animation tool, OK, and increase it so you can actually stand a chance of seeing it. All of the stars now, look, are in the same place. And suddenly, and let's slow it down a bit. Slow that animation down. Bang. So easy now to spot Pluto. One. So it starts here where my cursor is. There. Moves on to there. Yeah, because we're night missing there. And then it stops just there. This is what Clyde Tombaugh was doing in his image comparator, and his images won't have been aligned. But that beautiful piece of equipment that I showed you the image of last week, he puts one glass plate in the left-hand side, one glass plate in the right-hand side, and the first thing he does is he moves one of them around so that they're perfectly aligned. Then he flicks a little lever, and he looks at one, he looks at the other, he looks at one, he looks at the other. Suddenly, we can see so clearly a moving object in this astronomical image. Now, this is so important. This technique is so important in astronomical discoveries of all kinds. It's used for asteroids. It's used for things like this, Pluto. But it's also used for comets. So what you do there is you'll take a reference field one night. So if you're hunting for comets, you'll take a reference of this particular field, say, of the sky. And then the following night, you'll take another image of that field in the sky. And you'll blink compare them, or you'll use software to automatically do that for you and spot any moving object. It's also what members like Emmanuel Conseil do. And he, if you've been with Slooh for a long time, will know that he has had novae discoveries, supernova discoveries, and quite a few of those with Slooh. So what he's doing is he's taking a reference image of, say, the Andromeda Galaxy, and he takes a new image of that same region of the Andromeda Galaxy, and he blink compares them, aligns them obviously beforehand, blink compares them to see if there's a new object, a new spot of light flicking on and off. And if it is, chances are he's found a new nova or supernova. So this technique is used so widely in astronomical discoveries. It's something that, you know, we'll cover first of all when it comes to our image processing courses. So anyway, listen, I'm going to save all of those. Save all. There we go. Now then, if you wanted then to create a, in fact, I've got a nice little link somewhere here for you. Here it is. Need to just hop over. Do excuse me. Hop over here. There is in here. This little next bit I'm going to skip over quite quickly because you can go into the discussion boards here and there's a whole video showing you how to do this next little bit. Don't know who that guy is on there spoiling the view, but there is also some free software, the software that we're going to use now, because what I want to do is, let me just bring that up. And it's called Animation Shop, and here it is. I just want to check one thing. Did I save those? No, I didn't. Did I save those? Bear with me, folks. Okay, so which images did I just do there? Hold on 1 second, folks. Maybe one Okay. Right, so we are in some animation shop software, which is free. Download it from the discussion boards. And I'm going to use the wizard to do this. And so the first one was just saying, yep, use the same size as the first image frame. I want an opaque background. Scale the frames to fit, center in the frame. Yep, that's all okay. Next, how long do you want each of your images to display for? I've got in here 150th of a second, and I'm going to add some images, and we're going to add all 4 of our images in here. I love this software, and the fact that it's free is even better. Free stuff's good, or some free stuff's good. There we go. Look, we've inserted our images, and you can see here that because of the file naming, because the coordinates were the same, it's nicely ordered on the 21st, 23rd, 24th, 25th. So we've got 4 images there. Say next, say finish. And we can just zoom out a bit and we can see. So this is going to create an animated GIF. All right. And all you have to do is say File, Save As. And we're going to save it as GIF. I normally give it some name after that. I'll just say name. Okay. I'm not certain if I'm going to be able to display this for you. Don't think I'm going to be able to, because I haven't got a window set up for it. Let's have a look. I'll tell you what, I'll share the actual resulting animation with you afterwards, only because I haven't got a window open that I can actually share that with you in. But that would be it. So take a look at the animation that I'll share after the show, and that is as simple as it is to do any animated GIF using astronomical images. So we will take a look at that further on. By the way, I just wanted to show you one other little thing here. So here we are in a bit of image processing software, any layer-based image processing software. This is an old copy of PaintShop Pro, I think it is. And what you can do here to align your images, use one image as the base image. Then you can come over here, get your other image, you copy that and you paste it into your base image as a new layer. You can give it some transparency, and then you can move that to align with the next one. Make a new layer on the next one. Do the same thing with this one. Align it nicely. And then the very last, can you see this? No, you can't. Shout when you can't see stuff. I always forget to change the window. So I'm just copying this image and I'm pasting it here into my base image as a new layer. And there you can see we've got a single image with 4 layers. All we do, they're all aligned now, right? So all we have to do is save our background as a new image, then switch that off, layer 1, save that as, in fact, we need to turn up the transparency of them all. Save that one as an image, save that one as a fresh image, and save that layer as a fresh image, and those are all aligned. So if you've got any kind of image processing software that supports layers, then that's a really easy way for this kind of imaging. When you just want to make an animated GIF or something like that, how to align those images. Now, how far have we got? Oh, now I did just want to show one little thing here. Let me get rid of these images. No, don't want to do that. Let's just go there. I've got 2 Jupiter images here from a couple of nights ago. In fact, these are a few minutes apart, all right, using the Canary One Wide Field Telescope. So there we go. Now you can see, I'm hoping you can see on the screen. Just check that you can see it. The one on the left is fuzzier than the one on the right. Why is that? Did the telescope focus change over a period of 10 minutes? No, it didn't. So what else is causing that? Well, it's purely down to seeing conditions, how stable the atmosphere is above. And just what I wanted to show you here is how much you can improve your Jupiter images or any planetary images using Slooh, because we don't over sharpen the images. But take a look at this. In fact, we'll zoom in a bit, I think, on both of these so you can see it a bit better. And these are actually taken at the same time that Keith took his one. And we can see Ganymede's shadow there. But this is the fuzzier of the two. And I'm going to just add a little unsharp mask to it. And you can see there, does it really change it that much? Well, actually, what you can see is it's introducing an awful lot of noise. But that's because the image wasn't very good to begin with. Now, this image isn't that much better, but it certainly was better than the other one. And if we apply the same amount of sharpening to this one, it looks a lot better. Not quite so much noise. In fact, I probably wouldn't sharpen it quite that much anyway. So you can pull out this extraordinary amount of detail in your images, but the amount that you can sharpen any image by, and this goes for all image processing, is the better the original image, the more you can process it, the more you can sharpen it. So if you're new to image processing, make sure you take your Jupiter images from the Chile 1 wide field and try adding a little bit of sharpness, and you'll suddenly see the Galilean moons pop out and all sorts of other stuff. Now then, how are we doing? Well, we are. Right, I know what we're going to do. We were going to move on now to Slooh's observatories and telescopes. We've already said that we're going to look at the telescopes when we can see all of them live, right, at the same time, so that we can compare like for like telescope views, and it's going to be a lot easier for me to explain then the pros and cons of each telescope. So we can't do that now, but what I was going to talk about was the observatories a little bit. Now, we're going to overrun. Now, in 3 minutes' time, if you're watching in the Situation Room, the show will end. But if you then refresh that page, it will start again, just where I am. So make sure you press F5 or just refresh the page if you lose me, because I've got some cool stuff to show you about the observatories. We're going to hop back over to software here. We're going to take a little trip around Google Earth. How cool is this? So, Chile Observatory. Well, let's take a look. Let's take a look where the Chile Observatory is. Well, we know that it's in Chile. It's located at the Observatory of the Pontificia Universidad Católica de Chile, the Catholic University. And Slooh's telescopes provide full coverage of those rich southern hemisphere skies down there. The observatory actually is at a latitude, that's the north-south thing, 33 degrees south. So it's well placed for objects even close to the south celestial pole. So here you can see it. It looks a bit like a racetrack. Now, this is not Slooh's flagship observatory. It's a good place to be because we've got some great support from our friends at the Catholic University. But we're actually at the site of a huge health and sports club on the outskirts of Santiago. You can see down here, this is the huge clubhouse. This is the huge golf course that they've been building over the years. But up here you saw, to the left here, by the way, the big thing there in a bigger question center. But up here, ooh, this is cool, isn't it? The round thing up here. So the big white building, first of all, that is the university's observatory building, huge slide-off shed building there. And then the round white blob there is our 16-foot Astrohaven clamshell dome. And that's where we're getting live views from tonight, the Chile Observatory. But let's hop over now. Woohoo! And actually, we didn't quite see, did we, where we'd come from there. It happened so quickly. There's Earth. And we are going to go off to the west coast of Africa to the Canary Islands. And this is the volcano that we often talk about. This is Pico del Teide. But what you're seeing there, that's not the volcano. What you're seeing there in the background is the wall of the caldera. So this thing that we see that looks like the volcano is just a small, he says, small 2,000 feet high volcanic cone sitting on the edge of the volcanic caldera. So from there to the observatory is literally a stone's throw. And of course we get those marvelous views, don't we, from the Pico del Teide cam that look down onto the Canary Islands Observatory. So this is on the island of Tenerife. We'll zoom out a bit in a sec. But here's the observatory site. So this is what's managed by the Institute of Astrophysics of the Canary Islands. And we can zoom in. I quite like this image actually, because here are Slooh's domes. Now, this just happens to be when I was on site. That little white blob there isn't a dome. That's my hire car, because I was there to install a new telescope when the satellites went over the top and imaged that. But there you can see dome 1 is in the middle, dome 2 is off to the left, and then over here where this box is, that is where dome 3 is now. We can probably zoom out a little bit because you can see the rest of the site. This is our nearest neighbor. This has 2 2-meter telescopes in it. That's the stellar telescopes, enormous things in there. And then up on the horizon, right up on the ridge, they're totally iced up still, are the big telescope towers. Here are some of the other facilities here. This peculiar building here, which is a solar telescope, but it's a pyramid. Pretty amazing building. I think you've probably seen some images of that. So why the Canary Islands, and why is this the flagship observatory for Slooh? Well, first of all, you can see it is high up on the spine of this volcanic island of Tenerife. But it's more to do with where Tenerife itself is, surrounded by the Atlantic Ocean. So all of the air, all of the weather that hits the Canary Islands is usually coming across the ocean from the west. And when air is traveling across the ocean like that, it means that it's usually pretty darn smooth. So it hasn't gone over loads of mountains and stuff like that. So there's this really smooth layer of air. So there's, in the middle is the island of Tenerife. You've got the island of La Palma up here to the northwest. And that's where the IAC have another observatory situated up there. This is Gran Canaria, which is just one giant volcano. And you can see there are other volcanoes underneath. There's this kind of mantle plume underneath the Canary Islands, just like the Hawaiian chain of islands. And you can see there's quite a few that didn't quite break the surface. But so it's smooth air that hits the island. Plus we have the altitude, and that altitude of the Canary Islands Observatory puts us above what's called the inversion layer. And in the inversion layer is where 2 layers of the atmosphere meet, and that can be incredibly turbulent. It's normally where clouds form. And the fact that we're above it in the Canary Islands means that for the majority of the year, not at this time of year, but for the majority of the year, the clouds are below the observatory height, which means that we get great weather there for astronomical seeing. But the government of the Canary Islands knows just how important and prestigious having these enormous observatories and the largest optical telescope in the world based on their islands is. So there's actually something called the light law, and the light law protects the Canary Islands skies from light pollution. Aircraft aren't even allowed to fly over the island of Tenerife or the island of Palma. They have to skirt around it because they don't want to be spoiling the view for people. But anyway, that's a real quickie introduction. So we're not going to get on to even our image train of the focuses, filter wheels, and scientific grade CCD. So what we're going to do is next week, finally, we will dedicate the entire hour, and we'll keep it to an hour next week, to just talking about the observatories and the equipment. Now, if you've got any questions about the equipment, the telescopes that we're using, how the filter wheels work, how the focusers work, what's the CCD camera, you tell me how much detail you want to know about the observatory equipment, the equipment that you guys get to control every single clear night. And it's pretty remarkable, isn't it? When we look at this Google Earth view, and wherever you are in the world, you've been controlling a telescope on top of that mountain or way over here at the Chile Observatory from wherever you are around the globe. It's still pretty cool. I've been involved with Slooh for 14 years and it's still a pretty cool thing. Anyway, listen, take a look. The Chile telescopes are online. I am going to be back in just over 20 minutes time, just under 20 minutes time, and we are going to take a lightning quick look, and it won't be a long one, it'll just be a lightning quick look at our 2018 Slooh members Messier Marathon. And if you haven't done one before, please come along and join us. We're going to do a little bit about it tonight, just a brief intro. Then next week we'll talk in a separate show to the practical astronomy, so we'll still keep practical astronomy just to the telescopes and observatories next weekend. But then we'll have a separate Messier Marathon show, and we'll talk about the scheduling next week. And then the week after that, we'll talk about who's going to do what and how you can put your name down for specific objects. All right, so all of that to come. So don't forget, if you've got any questions, hop over to the discussion boards, and you'll always find, if you go over here into live casts and courses, I think it is, Practical Astronomy with Paul, you can post your questions in there, and we'll always get to those. Thank you, Muazzez. I haven't managed to check out your Pluto animation. Ooh. And Muazzez has also is also a member of the Near Earth Asteroid Monitoring Team. So it'd be interesting to see what she's done there. Anyway, share your results if you have done that animation thing. And as I say, just jot down any questions that you'd like to know the answer to about the Slooh equipment and observatory. So see you next week. Paige is back, I believe, on, I haven't seen a notice yet. But I believe she's going to be back on Wednesday with her next Intro to Astronomy course. If you haven't been seeing those, then make sure you catch them. And of course, you can catch them all if you go up to Livecasts and browse Livecasts, and you can see all the recent ones. So Paige was talking about the WOW signal last Wednesday, which was quite good. Anyway, listen, I'm going to see you in about 50 minutes time. So take care. I'll see you there. Bye for now.